Hello everyone, this is Miss Arlene, and this lecture video we will be having calculation of total resistance on a parallel and series circuit. So, for example, we have here the problems. Determine the equivalent total resistance for each of the following circuits here. The first thing that we need to do is to determine what type of circuit do we have here. For letter A, is it parallel or series? It is parallel circuit. How about for letter B? It is series. How about for letter C? It is series. It is series because all the wires, all the components, the resistors are connected in one single wire. Unlike on letter A, we have multiple wires drawn parallel on our battery wire. Now let us try solving letter A. So you have here the following. So for you to get, let us say you have 7 ohms, 5 ohms, and 2 ohms. For you to calculate the total resistance, you have to express each resistance in a fraction form, wherein you will get the inverse. And the formula for that is the parallel resistance formula. 1 over total resistance equals the inverse of the first resistance, second resistance, and third resistance. You just have to express this in fraction form. So if you have 7, then that will be 1 over 7 for first resistance. For 5 ohms, that will be 1 over 5. For 2, that will be 1 over 2. And then you have to add that. You will have 59 over 70. How did you get the 59 over 70? The first step is you get the least common multiple. And to get that, you have to find the prime numbers. So, you have 7, 5, 2 as your resistance, and all of these are prime numbers. And then you have to get the product of that, meaning to say you have to multiply. 7 times 5 times 2, that will be 70. That is why the 70 here will be the denominator. Now, the second thing that you need to do is you have to add. And for you to add that, you have to divide the LCD to the resistance. So, for first resistance, that is 1 over 7 equals 70. Then 70 divided by 7, the LCD divided by the denominator, then multiply to 1. 70 divided by 7 times 1, that will be 10. And then, same with the second resistance, 1 over 5 equals 70. 70 divided by 5 times 1 is 14. And then 1 half equals 70. For the third resistance, that will be 70 divided by 2, 35 times 1, that is 35. Now, for you to get the numerator, you just have to add this. That will be 10 plus 14 plus 35 equals 59. This is how you get the 59 over 70. You may divide 59 over 70. That will be 0.843, and then get the inverse of this value, which is 1 over 0.843, and that is equivalent to 1.2 ohms. This one. Now, or you may just flip this two, pagbaliktarin nyo, from 59 to 70, that will become 70 over 59, which is also equivalent to 1.2 ohms. Either of the two is correct. How about this one? This one is a parallel circuit as well. You have 9 ohms, 6 ohms, and 4 ohms. Now, for you to calculate the total resistance of a parallel circuit with resistors of 9 ohms, 6 ohms, and 4 ohms, we use the parallel resistance formula. 1 over total resistance equals 1 over the first resistance plus 1 over second resistance plus 1 over third resistance. The first step is you have to express each term as a fraction. So from 9, you will have 1 over 9. From second resistance, it will be 6, 1 over 6, and then 4 ohms will be 1 over 4. The next thing that you need to do is, as you can see, the denominators are different. They are different. They are not the same. And you can perform an operation if they are not the same in addition, right? Because our main operation here is addition. Now, for you to solve that, you have to get to find the least common denominator. The denominators 9, 6, and 4. The least common multiple of these numbers is 36. Again, the LCM is 36. Now, you have to convert each fraction to have a denominator of 36. So, the first step, you have the ohms of 9, 6, and 4, you have to do a prime factorization. We break each number down into its prime factors. So for 9, the factors of that is 3 times 3, 4, 6, that is 2 times 3, and then 4, 4, that is 2 times 2. And then you have to identify the highest powers of each prime. So we take the highest exponent of each prime factor. So you will have 2, the largest power is 2 raised to 2 from 4. And then for 3, that will be the highest power is 3 raised to 2 from 9. Now, after that, you have to multiply the highest powers together. So you will have 2 raised to 2 times 3 raised to 2 equals 4 times 9 equals 36. So the LCM of 9, 6, and 4 is 36. After you find the least common denominator, the next thing that you need to do is just like earlier, you have to what? You have to 36, that is the LCD, divided by the resistance, 36 divided by 9, times 1, that will be 4. And then 36 times 36 divided by 6, that will be 6 times 1, that will be 6. And then 36 divided by 4 times 1, that is 9. Now, the next thing that you need to do is you have to add the fraction. Again, you have 4 over 36, 6 over 36, 9 over 36 from here, from this one, from the operation. Yeah. Alright. Now, you have to add those fractions. They have common denominators. Just copy that. Then 4 plus 6 plus 9 is 19. The next thing that you need to do is you take the reciprocal. You get the opposite of this, 19 over 36. Flip that. You will have 36 over 19. And therefore, you have to compute the decimal value. Dividing that, that will become 1.89 ohms. You will have to use the omega symbol for this. So that is how you calculate the total resistance on a parallel circuit. Now, how about for series circuit? For series, for letter B here, you have 2 ohms and 5 ohms. You just need to add them. Okay, so the formula would be total resistance on a series circuit is equivalent to the first resistance and the second resistance, the sum of that. And then 2 for the first resistance, then 5 for the second resistance. You will now have 7 ohms. 2 plus 5 is 7, right? This is the resistance of letter B. For letter C, you have 3 resistance, 2 ohms, 5 ohms, and 7 ohms. You just have to add that in a series circuit. So 2 plus 5 plus 7, that will be 14 ohms. So that concludes this lecture video.